everyone. Our topic is on case study on testing of transformer, and these are the members over here. To brief you all with the abstract, improvement of transformer performance is significantly controlled by several factors including oil insulation property, core insulation, and inter-transformer winding insulation. In order to qualify these insulation properties, all this type of test must be conducted. This case study focuses on conducting several diagnosis tests, and to move on with the introduction. This report provides an overview of some of the most important transformer tests, their proposed procedure, and how they contribute to maintain transformer integrity. Different types of tests are conducted, and these tests guarantee that transformer operation within safe limit with little possibility of failure and a maximum of its operational lifespan. This is the aim and objective of our report.
So the diagnosis of test reviews we have done for this test, this many tests. So first of all, when we talk about turn ratio test, in this we have done for three methods. For voltmeter method, in this method what it is done is, first of all, no voltage is applied to the LV side of the transformer, and from the high voltage side of the transformer the voltage is measured. Then the turn ratio is calculated in this. In this voltmeter method, where it is applicable is it is simple and widely used for routine check. And comparison method, in this comparison method what we do is like we compare transformer, compare the transformer under the test with the standard reference transformer of known and verified turn ratio. And in this what we do is we give the same voltage. Same voltage is applied to the both of the transformer, and output of the voltage are compared. And this one is used for the calibration in the labs. And for ratio bridge method, in this method what we do is it is an instrument that balances the voltage ratio between winding using an internal bridge circuit. In this what it happens is it gives the digital and analog turn ratio, and this is more applicable in it can detect polarity, phase shift, and tap changer issues. And when I talk about insulation resistance test, this is the equipment that is used for insulation resistance test, and it is Vega made. For using this instrument, there is a test result that I will going to explain you all. In this test result, what we do is what we mean by GAR is the ratio of resistance at 60 seconds to the ratio of 30 seconds. We use this value, and when the GR is higher than 1.25, it is a good insulation, and in which we can see that here there is good insulation. For for primary to earth there is 1.2, right? So it is less than 1.25, but this one is also acceptable. In this what it says is it might indicate for early sign of surface moisture or aging of the transformer. Moving on, my friend will explain magnetic balance test.
So I will be presenting on the magnetic balance test. So the purpose, before moving on to the test, I would like to tell the principle of the magnetic balance test, that as the injecting voltage in one phase, as we inject the voltage in one phase, it will develop the same amount of the sum of voltage in the two other phases. And the purpose of the magnetic balance test is to detect the pole and imbalance. So the method that we call it in the magnetic balance test is to inject the single phase voltage on higher voltage delta and measure the phase voltage. So I would like to explain the test report on the magnetic balance test. So as I already mentioned that we have to apply the voltage in one of the phase. So when we apply the phase of 412 volt in RY phase, so it should give the sum of the other two phases is 413. So when we add this two, we get 413. So the test will pass. Now moving on to the next, we have the winding resistance test. So the winding resistance test purpose is to detect the shorted terms, loose connection, and tap changer issue. So to tell the procedure that's required in the winding resistance test, first we have to set the tap changer to any desired position and set the multimeter to resistance mode. And connect the red lead to HBR phase, black lead to Y phase, and measure the resistance. And we have to change the red lead to Y phase, black to B phase, and also measure the resistance. And the third, we have to record. We have to measure the red lead to the B phase, black lead to the R phase, and record the resistance. And this is the test report that we got from one of the substations. So, to conclude this test report, since the results are all conform, it means that the winding resistance test is good, so the test will pass. Whereas in the LV winding resistance test, since the Rn, Yn, Bn are opposed to each other, the test is good. Thank you.
We're going to go to this. As we all know that the oil is a vital component of the transformer. So to determine the performance of the transformer oil, we do the test. So the test area that we have for is Malwa substation. Most recently, the Malwa substation has changed the transformer. So there we have tested, we have done the BDV test. So while doing the BDV test, we have done the BDV before filtration and after filtration. So this is the result for average value. Before filtration is 76.1 kV and after filtration it is 85.2 kV. So according to IEC standard, if the BDV value is greater than 15 kV, that means the oil insulating property is good. Thank you.
Next case is battery group test. Purpose of this test is to confirm the winding conduction and phase displacement. And method is short circuit, short HPLC test, measure the induced voltage between the phases. And these are the types of battery groups that are present in the transformer. Through these two diagrams, we can deduce the mathematical results in three conditions. And next is the dissolved gas analysis, and the purpose is to detect the incident fault by the dissolved gases in transformer. This is mainly to detect the internal faults in the transformer. In this dissolved gas analysis, we have used the transport X on the instruments to detect. And outcome of this result is from the Malwa substations, and outcome is the gas concentration within the normal limits, no evidence of overheating, arcing, or partial discharge. And these things are the results. From here we can see that there is no fault in the transformers. White one is normal, and the yellow one it indicates the cautious, and the red one is for the warning. Overall result and discussion in all electrical and dielectric tests satisfies IEC and IEEE criteria, and the oil treatment enhance the insulation margins and no core, winding or tape changer anomalies detected. The transformer ready for energization and reliable operation. And scope of these studies to 630 kVA and 11 kV three-phase all-inverse transformer at the Marmar substation, and it is conform to the IEC and IEEE standard, and the result guided the maintenance decision and service readiness. Conclusion, the comprehensive diagnostics validated the 630 kVA transformers have, and preventive testing supports reliability and longevity, and regular monitoring